these things are going to be changed. So this differential, why differential? Here we are applying one pressure, here we people are applying another pressure, and across this one we people are trying to take the resultant output. Now how this is going to work? Here if you try to observe, this is the membrane, which is a movable one, this can be a you can consider this particular one as a diaphragm. This part is your glass film, and after applying a pressure as an input, how you are going to get the difference, that I would like to show. So at primary moment, if my P2 is greater than P1, whatever the condition that has been represented over here, so my P2 is greater, so pressure will be given to this part, and here you people are going to get the deflection. So change in the distance has been arised, and this change in the distance between these plates, there is a smaller variation in this particular plate. So due to this, the output will also change, and this output is calibrated depending upon the output. Now, if I change the configuration, that if suppose my P2 is going to be less than that of, if suppose my P1 is greater than P2. So P1 will be maximum one, P2 is the less one. So this particular part is going to be deflected like this, and again the resultant output generated will be more. But this parameter or these pressures P1 and P2, due to the difference, there will be a movement. But in this one, if both the pressures P1 and P2 both are equal, at that time the plate or the diaphragm between this particular casing will be same as it is, and the output will be the null one, or zero output will be generated at the output. So we have to take all these points under consideration while utilizing the differential pressure type of differential type of a sensor, or capacitive type of a sensor for the pressure measurement. This is delta cell type. So this consists of a fixed plate and movable plate. No doubt we have seen that particular aspect, that there is a fixed plate and there is a movable plate. Along with that one, you can utilize a diaphragm as one of the movable plate, as I have shown in the first figure, that diaphragm can be fully incorporated as a movable plate, whereas a fixed plate can be placed as a stationary one. So when pressure is applied, due to its property of flexibility or elasticity, there will be a movement of the diaphragm, and this movement of the diaphragm will vary. The change in the displacement leads to change the capacitance, because we are using the diaphragm as one of the plate. The capacitance is placed in one of the arm of the capacitive bridge. No doubt similar to that of your resistance measurement in the Wheatstone bridge, this capacitive type of bridge can be designed to obtain the resultant output. So the output voltmeter is calibrated in terms of input applied pressure, because that is nothing but that is the function of input applied pressure, which leads or which cause the deflection or change in the deflection of the plate. So this was the part for the change in the deflection. Now the pressure under measurement, whatever the pressure or whichever may be the pressure which we people are interested to measure, that pressure which we are applying, that should be applied at the input and can be measured, that which is to be measured. So depending upon the input pressure, we are the deformation to the diaphragm will be generated, or diaphragm will move depending upon the applied input pressure. So with reference to that of input applied pressure, diaphragm is either going to move to forward direction, or either going to move towards the backward direction. So change in the capacitance or change in the position is going to take place. So here the distance plays a significant role, and that distance is nothing but it is the distance between the plates. As it changes, that will lead to change in the capacitance depending upon the movement of the plate as we have applied the pressure. So that change is nothing but it is the applied pressure. So the output voltage which is developed is directly calibrated in terms of your this one. It is directly calibrated in terms of your applied pressure. So now, what are the different types of application that has been commonly used utilizing a capacitive type or rather than that various application of the pressure measurement? So, change in the capacitance or the capacitance pressure transducer actually are originally developed for the use in the low vacuum. So, where there is a necessity of the vacuum measurement, low vacuum measurement, in that particular place, this capacitive type of pressure transducer can be used. So, depending on the type of pressure, the capacitive transducer can be used. So, what is the significance of that? Depending on type of pressure, the capacitive type of transducer, whether we people are utilizing a absolute gauge or whether we people are utilizing a differential transducer. So, that particular with reference to that of absolute gauge or differential one means either we are using two pressure or either we are using single pressure. So depending on that, the capacitive type of pressure transducer can be used. Okay, the material that has been used for the designing of the capacitive type is stainless steel is the most common material that has been used for the design or development of a diaphragm uh, for capacitive type of a sensor or even in common also, because here the diaphragm is playing the role of one of the movable plate in capacitive type of pressure measuring devices. Over here, that for corrosive high nickel steel alloy such as inconel or hastolene gives a better performance. So other than commonly though we people are using the stainless steel because they are available in the market, but if in some of the cases corrosive type of material or environmental condition that is present, to avoid the corrosion of the plate in that respect, we can use a nickel steel alloy also that will avoid the corrosion wear tear of that component. Then inconel or hastolite, these are providing much more high or improved performance of this while designing diaphragm for capacitive type of transducer. So the diaphragms, they are usually a metal or a metal coated quartz. A single diaphragm that can be directly used for pressure measurement can be, though I have mentioned over here for capacitive type, in capacitive type it should be metal or metal quartz. But however, it is not that true that all the aspect, if suppose a simple application I am utilizing without a capacitive type, in that case there is a no necessity to use a metallic type. You can use even use a non-metallic type of a diaphragm also. But when we are using this one as a capacitive or change in capacitive type of a sensor, in that case we have to consider such a type of or this particular type of concept that metal or metal quartz can be used as a diaphragm one or designing that particular movable plate, and that particular movable plate is actually acting as a diaphragm. So tantalum is also used for a highly corrosive high temperature applications. So this tantalum also plays a significant role over here because this can be fruitfully incorporated in the corrosive environment also, and even in case of a higher temperature, because this is having the concept that uh, if temperature increases, the melting problem or the deflection which is to be carried out, depending on which we are going to get the output, that will not hamper due to the change in the temperature. Because what happens, some of the metals are having the property that they can change depending upon the variation in the environmental condition. But tantalum is the material that is much more robust with reference to that of corrosive environment and high temperature, compared to that of your steel alloy, nickel steel alloy, or Incoal, Hastoline that has been given. Another material that can be used is a silver diaphragm. This can also be commonly used, but this is cost effective, that can increase the cost also for the pressure measurement. As we people are well aware that this is the ornament that is much more costly ornament, or this is the costly metal. So this people are avoiding a silver type of a diaphragm for the designing purpose of the pressure. But the above one can be incorporated. Fluorine and other halogens in their elemental state can also be used